Hi learners, in this video we will see about signals and system, particularly signal representation. The signal is mainly classified into two types. First one is a continuous time signal, another one is a discrete time signal. In this video we will learn about a representation of discrete time signal. Discrete time signals are signals which are defined only at discrete instant of time. For those signals, the amplitude between the two time instant is just not defined. For discrete time signal, the independent variable is time n and it is represented by x of n. These representation is mainly classified into four types. First one is a graphical representation, second one is a functional representation, third one is a tabular representation, and fourth one is a sequence representation. First we will see about graphical representation. This is a graphical representation. We can represent the signal in a graphical manner. Consider a signal x of n with values. Here this is n values. In x-axis we have n values. In y-axis we have x of n values. For example, n values equal to 1 means the x of n values equal to 3. That is, here they are denoted as x of minus 2 is equal to minus 3. Here x of n values equal to minus 2 means the x of n values equal to minus 3. Suppose n values equal to minus 1 means that is x of minus 1 is equal to x of n values equal to 2. That is x of minus 1 is equal to 2. For example, n values equal to 0 means the x of n values equal to 0, because in this graphical representation we have n is equal to 0 means the x of n values equal to 0. Therefore, x of 0 is equal to 0. We can represent the input and output of the signal values like this. That is, x of n is equal to x of n is equal to x of n. That is, n value is equal to what is the n value? That value is a output of that is x of n values. This is a graphical representation of discrete time signal. Next one is a functional representation. Functional representation means we can represent the signal in a functional manner. That is, x of n is equal to, for example, x of n node value is 2 means for n values equal to minus 1. We can represent the n values in this order. What is n value? The corresponding x of n values equal to is denoted as x of n is equal to some kind of variable signals. That's it. This is a functional representation. Next one is a tabular representation. Here we just learn about tabulation representation. We can represent the signal in a tabulation. That is, what is n values, what is x of n values. For example, n values equal to 0 means the x of n values equal to 0. Suppose n values equal to 2 means here x of n values equal to 1. This is a tabular representation. Next one is a sequential representation. Here we can represent the signal in a sequential function. That is, x of n is equal to minus 3, 2, 0, 3, 1, 2. The arrow mark is denoted as initial value of the signal. Next one is a elementary signals. The basic standard signals are unit step signals, unit parabolic function, sinusoidal function, complex exponential function, unit ramp function, unit impulse function, and real exponential function. First, we will learn about unit step signal. Unit step signal means that is u of t is equal to 1 for t is greater than equal to 0. Other than that, the value is equal to 0. A step signal is one of the standard test signal. It is also known as a Heaviside function of input signal. The magnitude of step signal is a constant. A step signal exists only for positive values and 0 for negative values. It is denoted by u of t. Mathematically, u of t will be constant for t is equal to 0. That is for positive values, and will be 0 for t is less than 0. That is for negative values. It represents sudden changes in the reference input. It is used to analyze system response to sudden changes in the reference input. It is defined by its magnitude. This is a mathematical representation of the unit step signal. For a is equal to 1, this step signal is called unit step signal. For magnitude is 1. U of t is equal to 1 for t is greater than equal to 0. Suppose t is less than 0 means the value is 0. This is a graph of the unit step signal. Here we know that is t value is varying, that is only one values, the u of t is equal to 1. Here the t, this is a u of t. In x-axis we represent the time values. In y-axis we represent u of t values. When t is equal to 1 means that is u of t is equal to 1 means the t is greater than 0. Next one is application of step signal, system transition and switching events. Step signals are commonly used to model sudden changes or transition in systems across various engineering domains. Next one is a control system analysis. Step signals are used to analyze the response of control system to sudden changes in reference input or disturbances. By applying step inputs to control system, we can evaluate system stability, transient response and performance. Third application is process control and automation. The step signals are used in process control and automation systems for modeling sudden changes in process parameters such as flow rates, temperature or chemical concentrations. Next one is advantages of step signals. Here I have mentioned some basic advantages of step signals. First one is a simple to generate. Step signals are simple to generate and understand, making them accessible for both theoretical analysis and practical implementation. Their straightforward nature allows us to easily generate step inputs using simple control mechanisms or software tools. Next one is a system response to sudden changes. Step signals are particularly useful for studying the response of systems to sudden changes or transition. By applying step inputs to system, we can observe and analyze how the system reacts to sudden changes in input. Next one is a stability analysis. We can determine system stability by observing how the system responds to step input and by analyzing characteristics such as overshoot, settling time and steady state error, which are indeductible of stability properties. Next one is a versatile application. Step signals are used in control systems, signal processing, electronics, motion control and robotics. In our next video, we will learn about ramp signal and other kind of standard signals. Thank you.